Welcome to solutions video number 1. Today we're going to review the difference between homogeneous and heterogeneous mixtures because that's going to be important for us as we move forward throughout this chapter, and we're going to introduce some solution vocabulary. So to start with, let's review what we learned about homogeneous mixtures. We know that a mixture is when you take two or more substances and you combine them physically. We know that when we're talking about a homogeneous mixture, the particles are arranged evenly or the same throughout. So remember we talked about the prefix homo means the same, so particles will be arranged the same throughout the entire solution. Typically solutions appear clear and transparent, which means we could see right through them, or often they'll appear as one phase, so all as like an aqueous or liquid phase. The particles that are dissolved are so small we can't see them. So remember when we were looking at any type of Regents questions about homogeneous mixtures or how to identify a homogeneous mixture, every time we see this word dissolved, that's our key indicator that it's going to be a homogeneous mixture. Here's a picture showing you what a homogeneous mixture looks like. Here we have salt dissolved in water. So we have sodium ions, chloride ions, just showing you how water will really wrap itself around the ions. And we'll talk about that more later on in this chapter. Heterogeneous mixture is when you have two or more substances that are not evenly spread or dissolved throughout the solution. So we will not use the word dissolved. They do not mix. So the properties of each of the different substances have different chemical properties and physical properties. So they will not mix. Okay, so how do you make a solution? Well, there are two pieces or two parts to a solution. We have the solute and we have the solvent. The solvent is what we call the dissolving medium, or what's going to do the dissolving. So whatever we're trying to dissolve will be dissolved into the solvent. So when you try to make, let's say, iced tea, you dissolve sugar in water. The water is the solvent. The solvent is also the one that you have more of, the one that's present in the larger amount. And it doesn't matter, it's not phase specific. So a solvent could be solid, liquid, or gas. So the other part of a solution is a solute, and that's what you're trying to dissolve in the solvent. So I remember that the solute is what you, has a U in it, it's what you put into the solvent. And once the solute is dissolved into the solvent, it will become evenly dissolved. So you could stir it up, and then it would dissolve into the solvent. So what happens when you put a solute in a solvent is, let's say you have salt entering into water. Let's say you poured a spoonful in at the top of a water cup or something. The solute will slowly break down and move throughout the liquid phase, and they interact with each other, the solute and the solvent, until eventually they become evenly spread out. So another word for a homogeneous mixture in which the solvent is water is called an aqueous solution. And I know we've seen aqueous before, and we've seen this AQ after answer choices. And we know that aqueous means that we're talking about a homogeneous mixture. So we could just be a little bit more specific in the language that we use when we're talking about aqueous now to say that, oh, when something is aqueous, that means that the solvent is water. So you're dissolving something in water. So for example, when we see NaCl, this is really sloppy, I apologize. This is on my laptop today. When you see something like NaClAQ, that just means salt is your solute. This whole thing, salt, is a solute, and AQ means the solvent is water. While we're on the topic of water, it'll be good just for you to remember moving forward, and as we'll continue talking about water a lot actually in this chapter, that water is a polar molecule, meaning that it's an asymmetrical molecule. Remember, it has its bent structure, and that water has these hydrogen bonding as force of attraction between them. So the name of the process for when a solute dissolves in a solvent is called solvation. So as we were discussing before, if I have salt water, NaClAQ, the solute is the salt, the solvent is the water, and the salt will evenly become distributed into the water, forming a solution. When the salt dissolves in the water, it will dissociate or separate into Na positive and Cl negative ions. The water molecule, remember, since it's polar, has this unequal charge distribution. The oxygen is partially negative and the H is partially positive. Will surround these ions and hydrate them. So when we look at the water molecule, we have H2O. The O, being partially negative, will be attracted to the positive Na. And the H's, which are partially positive, will be attracted to the negative part, the Cl ion. But in general, whenever any ionic compound dissolves in water, since hydrogen is partially positive, it will be attracted and rip apart the negative ions in the solution. And the oxygen, which is partially negative, will be attracted to whatever ion is positive of the ionic compound and kind of rip it apart. We slowly have that these ions are being pulled apart and surrounded by the water molecules. So lastly, I'd like you to write down these three equations. We're going to discuss them in class tomorrow. But what it's showing you is what happens to each of these ionic compounds, or salts as we can call an ionic compound, when they are placed into water. They separate out into their positive and negative ions, and we just have to balance out so that we have the correct number of each. So copy those down, then you are done.